Hey everyone, welcome back. So today we are going to solve another problem. Remove duplicates from the sorted array. This is easy problem from the Leetcode. So in this problem, you have given an array which contains duplicate data in a sorted manner, and you have to remove duplicates from the sorted array. So our array will become 0, 1, 2, 3 and 4. So you need only unique values from the array. But in the Leetcode there is some changes how you are going to output your data or array. According to the Leetcode, you don't have to return new answer array. Instead they want a key which will be the size of the array which is containing number of unique values. So if you look at it, here we have 1 2 3 4 5. So k should be 5 because it only contains unique values. So before going to this, let's first see how we can solve this problem if we are not solving on the Leetcode. So we have this array and you have to return a answer array. So this will be your answer array. So what you can do, you want to remove duplicates. So we have learned one data structure which is set, which will give you unique and sorted values, right? So you can insert your values from the array to the set, and from the set you can insert your value to your new answer array. In this way you can remove your duplicates, right? So if we write a code for this, we will declare our set, then we will run our loop into this array, and we can also get a size of the array, and we can insert values from the array to the set. After that we can declare answer vector and iterate over the set and push back the values from the set, right? In this way we can duplicate our values and create a new answer array. But according to the Leetcode, you can only return your answer in this form. Means you will be modifying your original array. Means you will be having only nums, and you will be modifying such that your unique value will comes at the front and your all the duplicates value will be at the end, and you have to return the key which is the number of unique elements. So if we take an example, you have given something like this, and if you modify this array, this should become like this, and your k value become 2 because you have only two unique values and the duplicates value will be at the end. Similarly, if we take our example and if we modify it 0 1 2 3 and 4, so these value will come at the front, and the remaining value you can put them in any order, it doesn't matter because we need only these values and the value of k which will be 5 here. Okay, so for this we will be using two pointer technique. So for this we are going to use two pointer technique which is optimize, but you can also use set, but set will take space complexity of big of n, which is extra space. But question asked us to modify original array, so he does not want to use extra space. So for this we are going to use two pointer technique. So we have to somehow bring all the unique value at the front and the duplicate values at the end. So we are going to use two pointer. One we will be starting at the 0th and the j will be starting from the next of it. So ith pointer will be handling unique values and jth pointer will be iterating over the values. So initially values at the ith and jth are same, so we will just move our j only because we already have a unique value at the 0th position. Now if you look at it, our j at the position where there is a new value. So how we can check if they are new value? We can compare values from the ith and the jth. If they are not equal, we can say we got one more unique values. So in this case we will move our I here and replace the value of the ith with the value of jth. Okay, so in this case we will assign our value at the ith with the value of jth. Okay, here you can see we updated our 0 with the 1. So Leetcode doesn't care about the number of zeros, ones and whatever. He only cares about the unique values. Now we updated our unique value at the ith position. Now we can move our j. Here you can see both of them are same, so we will do nothing. Then we will move here. Now you can see we have another unique value, right? If we have unique value, we will move our I to the next position and update it with the 2. Right, now if you check they are equal, so let's move over j. Here they both are equal, let's move over j. Now here you can see we got another unique value, so in this case we will move over I and update value at the ith position. Now let's move over j again. Here you can see value at the ith and the jth are same, so we will move our j again. Now in this case our value at the ith and jth are not equal, so we can move our I and update the value with the 4. Now if you move your j, the loop will end, right? So in this range we are able to get our unique values. And if you talk about the number of unique values, it is I plus 1, right? Because it is a 0 index, 0, 1, 2, 3, 4, and we have values 5. So if you return a I plus 1, it will return your unique numbers. So what's happening here? We are using 2 pointer techniques. In this case we are taking I and j. Ith pointer is handling unique values and the jth pointer is iterating over the values and comparing with the values at the ith position. As long as it finds the unique values, it will update the value at the ith position. Let's write a code for this. Int I equals to 0. So this is our ith pointer which will be starting here. Then we will run a loop of j which will be starting from the position 1. If our nums of I not equals to nums of j, means our value at the ith position and the value at the jth position are different, then we can move our I and update the value at the ith position. Else our value are same, the j will automatically move to the next pointer, so we don't have to write the condition for this. And we have to return I plus 1, because till ith position we are storing our unique values and the number of unique values will be I plus 1 because it is a 0 based index. So in this way we can solve our problem with the time complexity of big of n and space complexity of big of 1. Okay, so we only have to handle one case where the values are not same. If they are not same, that means we have new unique value. Okay, let's take one more example so you will be able to understand. So we have something like, okay, we have I here and j here, both of them are same, so we will move our j. Now both of them are different, so we will move our I first, then we will update our value at the ith position. Now we will move our j, both of them are different, then we will move our I, then update our value at the ith. Now let's move our j again, both of them are different, then we will move our I and update our value. Let's move j, both of them are same, nothing. Let's move over j. Our loop stops here. These are unique values and the number of unique values are I plus 1, 0, 1, 2, 3. So I at the 3th position and values are I plus 1, which is 4. So that's how we are solving this problem. Now let's write a code for this. So this is our problem. Here you can see they have given a in place. In place means you have to make changes directly into the given array. Okay, so you have array like this and you have to arrange the unique values at the front and the dash are anything. It does not matter what you have leave beyond the returned key. So key is our number of unique values. After whatever the values are there, it does not matter, right? So you have to only return key or I plus 1. The Leetcode will automatically check your answer. Okay, so let's first declare our size of the array. After that, let's declare I equals to 0 and j equals to 1, j less than n, j plus plus. If nums of I not equals to nums of j, that means we have our unique value and we will move our I and update value at the ith position with the value of jth position. After that we can return our I plus 1. Okay, so our code is working. Okay, here I used for loop. You can also use while loop also. In this case you can declare j equals to 1 here, and then while j less than n, and here you have to update your j. So you can use whichever loop you want to use. Okay, so time complexity is big of n, space complexity is big of 1. So these kind of pointer techniques will come frequently, so try to practice or dry run it on different examples, so it will be clear to you. Until then, thank you everyone, have a nice day.